Welcome to the Tejano virtual event Happy Math Hour, weekly interactive math reviews for Math 1314 and Math 1324, presented by Professors Yvette Chuca, Ruben Carrizales, and Albert Isasi. Today's section is about factoring, and the section will be recorded so that you may come back to it later if you need, and so others who may have missed out on today's event will be able to come and watch it. Also, this event will provide the handout passport points. The code will be posted on the chat at the end of the session for Tejana passport points. So now at this time, please mute your mix for based on experience. Otherwise, the feedback will interfere with the information we'll be sharing today. Without further information, here's our presenter, Professor Ruben Carrizales. Thank you.
Good morning, everyone, and thank you so much for that presentation. Welcome again to Friday Happy Math Hour. Hopefully, you're all doing well. So today's session, we're deviating a little bit of the material. We do have one session today only that is beneficial for all math classes, and it's factoring, which is needed in all classes. So let's go ahead and get started. Um, so again. Factoring not only is taught in our NCBM classes, but their factoring is used in all majors of mathematics. Okay, so whether you're in the business in the 1324s or in the science 1314 classes, again, you're gonna use factoring intent extensively. So it's a good thing to review. So um, for instance, what is the purpose of factoring? And factoring, especially when we have long polynomials, it allows us to find where um, on graphs these polynomials cross the x-axis. So one of the things that leads us to to solve polynomials is using factoring. And again, these are some of the things that you'll see in books, like whenever they say find the x-intercepts or find the solutions of the graph or find the zeros or find the roots. um, all of these are talking about the same thing. And again, they're asking us where in the graphs they cross the x-axis. And again, factoring helps us in finding these types of answers. So again, in real life, again, we need to find these particular points. And again, as you can see, most of the time, especially both in your business class or your science class, it's always these curve shaped graphs, right? These parabola looking designs in the real world. All right. So some of the things that I'm going to introduce to you that come in handy to help us factor is these factor sheets. But again, hopefully, we you are familiar with your timetables and we can figure these out pretty easy. But again, these are things that are accessible to you, so you can use as an aid. Okay. So here are some basic steps in order to factor. So the first step is always factoring what's called our greatest common factor, and you'll help me refer this to this as always the GCF. Um, and what this is what is the highest factor that can be factored out of a polynomial. Okay, and then the second is determine the number of terms that you're looking at, and always that will always help us decide what type of factoring technique we need to use. Again, and here are some examples of some of the main factoring techniques that we're going to use. Again, these are the four most uses of factoring in: the GCF, if we have two terms, or we have three terms, or if we have four terms. And again, I'll explain each and every one with an example. Okay, so before we get started, let's take care of some vocabulary. Okay, so a quadratic expression is an expression involving a squared term. So for example, anything that has an exponent of a 2, that is considered a quadratic expression. And then the word factor means the numbers that multiply together to get another number. That's what factor is. Okay. All right, so let's see an example of what are the factors of 12. So the factors are 12 are all those numbers that I can multiply together that would give me an answer of 12 or the value 12. Okay, so um, here they are. So we have 1 times 12 will give me 12, 2 times 6 will give me 12, and 3 times 4 will give me 12. So the factors are 1, 2, 3, 4, 6, and 12. And the reason why we list them as individually is because, again, I can get 12 by 12 times 1, or 6 times 2, or 4 times 3, right? The order doesn't matter. But again, these are all the factors. These are all the numbers that I can multiply together that would give me a value of 12. Okay. Now, what are the factors of 20? And again, I will do the same thing. The factors of 20 are 1 times 20 is 20, 2 times 10 is 20, 4 times 5 is 20. So the factors are 20 are the 1, 2, 4, 5, 10, and 20. Okay? So this is an example of finding the factor. So now, if I want to find the greatest common factor between two numbers, again, the greatest common factor, we're just going to keep on referring to it as our GCF. And the GCF of a set of numbers is the largest factor that all the numbers share. Okay, so for instance, in this example, what is the GCF of 12 and 20? So again, here are the list of the factors of 12. 1, 2, 3, 4, 5, 6, and 12. Um, for 20 are 1, 2, 4, 5, 10, and 20. And these are the numbers that they share. They both share a 1, they both share a 2, and they both share a 4. But what is the greatest common number that they share? So the answer would be 4. So this is my GCF of 12 and 20. The greatest common factor is 4. So this is how we determine our GCF. All right. So again, we can use a factor sheet to help us um, with these factors. Again, if we're a little rusty in our on our multiplication, right? So let me show you how we can use this factor sheet. Okay. So for example, I'm going to do the same problem all over again, but I'm going to use the factor sheet to help me. Okay. So what are the factors of 12? And again, the factor sheet gives me all the numbers that I had just found out when I was doing the multiplications. And these are it. Excuse me. Then I would find the factors of 20. Again, on the factor sheet, the 20 is there with all its multiples that give me 20. Again, they're the same numbers that I discovered earlier, but on the factor sheet, it's giving it to me. So again, I know that the GCF is 4, just as before. So on the factor sheet, you would look at the box for the 12, the 1, 2, 3, 4, 5, 6, 12. That's what all the numbers that multiply together can give me 12. Again, the factors of 20, I would just look at the box of the 20 that has 1, 2, 3, excuse me, 1, 2, 4, 5, and 10, and 20. And then I would circle the one that is the highest number that they both share. And in this case, again, it's the number 4. Okay. All right. So hopefully this is review. To help you again. And it's worth it to review this because again, we will be using it a lot in our classes. Okay, so let's look at another example. So again, what we just saw was step 1, finding our GCF, or again, the greatest factor to factor out. Yes? Now, again, let's practice 2 more numbers. What is the GCF of 20 and 30? So I would do the same process. Okay, so find the factors of 20 and 30. That's my first step. So the factors of 20, again, are 1 times 20, 2 times 10, and 4 times 5. The factors of 30 are 1 times 30, 2 times 15, 3 times 10, and 5 times 6, right? So again, what do they share? They both share a 1 and a 2, and they both share a 10. So what is the greatest common factor for these two, or the greatest number value? So the GCF is 10, right? That's our biggest number that they both share. All right. So now let's look at the GCF of when they give us something with variables. So for instance, in this case, what is the GCF of x squared and x cubed? So it's the same process, okay? So look at x squared first. X squared, if I expand that out, what that really means is that I have two x's, x times x, okay? And I'll grab x cubed. X cubed, that means that all I have is x times x times x, three x's, okay? So then I find out what they share, right? So they both share two x's, right? So since they both share two x's, the GCF is just the x squared. And an observation that you should notice here when they're doing variables, we really don't have to count them. Um, if you realize this example, the GCF, when we have the same variable or same base, um, it's the one with the smallest degree or the smallest exponent. That's going to be your GCF. Okay. All right. So let's put it together. What if I wanted to factor out um, or find the GCF of 30x squared plus 20x cubed? Okay. So again, I would um, I would know that my GCF is 10x cubed from the previous examples. I know that the highest number that 20 and 30 share is 10, and I know that the highest variable that x squared and x cubed share is x squared. So I know that this is my GCF. Now, if 10x squared is factored out, what is left over? So what I like to do is I say to myself, okay, I'm taking out a 10x squared. What do I have to multiply to 10x squared to get back 30x squared? Well, on that first one is a 3, right? I need to multiply it 3 to get back the 30x squared. What am I to multiply to 10x squared to get back 20x cubed? Well, that would be a 2x. 2 times 10 would give me the 20, and x times x squared would give me that x cubed. Okay, so again, this is how factoring works. Um, let's look at this other example. Okay, what if we have x times 2x minus 5 plus 2 times 2x minus 5? What is the GCF of this example? So one of the things hopefully you notice that they both share a 2x minus 5. So that would be my GCF. The thing that these both two expressions share is that 2x minus 5. So that is my GCF. So if that's my GCF, what was left over? I had a leftover x from the first one that I took out, the 2x minus 5, and I have a 2 that is left from the other expression. So what's left over? Just the x plus 2, right? So I factored this out. Um, this this addition became a product, right? This 2x minus 5 times the x plus 2. Okay, so that would be my that would be my answer for the factorization of that example. All right, so again, this example is crucial for factoring polynomials that have 4 terms. Okay, so let me show you how we might see it in our classes. Um, what we're going to see it is all these numbers being multiplied and added together. Okay, so we have 2x squared plus 8x plus 3x plus 12. And what you would do when you are factoring 4 terms, we always want to take the approach of factoring by grouping. And the best way to factor by grouping is to always just cut um, these 4 terms in half, 2 on one side and 2 on the other. Now sometimes it's good to rearrange them to help us factor, but you do not have to do that. Okay, if you just cut it in half, um, the factor by grouping will always work. So for instance, again, I'm going to cut this in half and I'm going to create 2 groups. The first group is this group made out of the 2x squared plus 8x, and then the second group, the 3x plus 12. Okay, so let's go ahead and simplify each one independently. So I'm going to take a look at the group 1 first, but I'm going to look at just the numbers first. I am dealing with a 2 and an 8. So what are the factors of 2? The factors of 2 are 1 and 2. What are the factors of 8? 1, 2, 4, 8. So the GCF of 2 and 8 is 2 because that's the highest number that they share, right? That's why they're in green. I only share a 1 and 2, but the highest number is the 2. Now, let's go ahead and still with group 1, we have two variables. We have the x squared and the x. And again, as our little notation before, we know that the GCF is always going to be the variable that has the smallest exponent. In this case, we have one x only, so that is my GCF, x. So the GCF for 2x squared plus 8x is just 2x. All right, let's look at group 2. Okay, group 2, I just have a 3x plus 12. So all I have to do is worry about the numbers because the 12 doesn't have an x. So my only concern is just the numbers 3 and 12. So 3, the factors of 3 are 1 and 3. The factors are 12 are 1, 2, 3, 4, 6, and 12. Again, they both share a 1 and 3, but the GCF is the largest number, so the GCF is 3. So the GCF for 3x plus 12 is just the value 3. So I'm going to factor those out from my groups 1 and 2. Okay, so when I factor out a 2x and a 3, a 2x from group 1 and a 3 from group 2, what's left over? What's left over is the x plus 4 for the first group and an x plus 4 from the second group. Do you see we have the same situation that we had last time? We have two expressions, this addition, that they both share something that they're being multiplied with, the x plus 4 with the x plus 4. Now this x plus 4 is our GCF. So we take out our GCF, and what's left over? All we have left over is a 2x plus 3, and we multiplied it. And we have factored now this for term polynomial, and our GCF or our factorization of 2x squared plus 8x plus 3x plus 12 is just x plus 4 times 2x plus 3. Okay. All right. So again, determining the number of terms that we want to factor will help us factor. And as you can see right now, what I just gave an example was that 2c from the first slide that I gave you. We were factoring by grouping because we had 4 terms. Okay. But now let's look at, again, this explanation a little bit in detail. We use factor of grouping to separate into two groups. When we separated them two groups, it allowed us to factor the GCF on both, and that result gave us the GCF that's for all 4, right? So we were able to factor out the 2x minus 5, and we just multiplied to what's left, okay? So again, this is kind of a way to factor. In a sense, it's just we're breaking it into pieces. Okay. All right. So what if we only have 2 terms? So the first type of factorization that we have that we can factor when we have 2 terms, if our terms are perfect squares. Now, if they are perfect squares and the squares are being subtracted from each other, they're going to factor always in this notion. Okay, so let's say that I have an x squared minus y squared. The factorization of that's going to be x minus y times x plus y. Okay, so another word for this type of factorization is the difference of squares. Okay, so whenever you have perfect squares that are being subtracted, we apply that something that's called a difference of squares, and that just becomes x minus y times x plus y. Now we have perfect squares that are being added to each other. These guys are already prime, and that's the factorization. They just stay that way. We cannot, I guess, break it down any further than how it is already. Remember, when we say prime, it means that the number can only be multiplied by itself and 1, right? So the x squared can only be multiplied by another x and or x squared times 1. Yes, so that's why we call it prime. Okay, so these are examples of primes that expand to this format, the x minus y, the x plus y, the x squared minus 1. Again, 1 can be written as a square, 1 squared, but 1 squared is just 1. So that's why we don't, and that's why it's just 1. But this one came from the x squared minus 2 squared. 2 squared is 4. The third one is x squared minus 3 squared. 3 squared is 9. Again, so on and so forth. So these are all the squares. And if you see, they're just the multiples of x minus y times x plus y. Yes? So again, please keep in mind the squares that have a addition between them, they're already prime. We cannot expand or simplify any further. These are only applied to perfect squares that are being subtracted with each other. Again, difference of squares. Okay. Now let's move on to perfect cubes. Okay. So now when we have x cubed minus y cubed, this expands with this pattern. We have x minus y times the x squared plus xy plus y squared. Now this one does have an expansion formula if we have perfect cubes that are being added with each other. So the x cubed plus y cubed will result in now x plus y times x squared minus xy plus y squared. Okay, so let's look at an example of these. Okay, so for instance, I want to factor x cubed plus 125. So what I see here, 125 can be written as a cube as 5 cubed, right? So that's what my y cube will represent. The x cube was already in its cube form, x cubed, but the 125 was converted into the 5 cubed. Now I just apply it into my formula or my pattern. The x is the 5, the y is the x is the x, the y is the 5. So that there we have the x plus 5. Now x is 5, so the x is still x, excuse me. So we have the x squared minus xy. So again, x is 5, the y is x, so that gives me minus 5x. The y was 5, so 5 squared. So let's simplify. So our factorization is x plus 5 times x squared minus 5x plus 25. Again. So again, we need to know this pattern in order for us to um, be able to represent it. Yes. So for instance, in this one here, let's say that we have 27x cubed minus 64y cubed. Okay, we want to put it in a pattern where we have a perfect cubes. So now we're dealing with a number and the variable. So the 27 can be turned into a number that has an exponent of 3. That's 3. 3 cubed will give me 27. Again, the x cubed is already in a cube format, but again, I can rewrite that as 27x cubed can be rewritten as 3x to the third power or cubed. Same thing with the 64. 64 is a number that can be written as a cube. If I write 4 cubed, that will give me 64. And the y cubed, again, I can simplify it into just 4y cubed. So again, we have a minus between them. So we're going to do the pattern where we have x minus y with the x squared plus xy plus y squared. And again, it just becomes plugging in scenario, right? My x is 3y. My x is 3x. My y is 4y, and I'm just plugging them in, right? So once I plug them in, I get the factorization of 3x minus 4y times 9x squared plus 20xy plus 16y squared. Okay. All right, so that takes care of, again, just greatest common factor, factoring with 2 terms if they're prime, factoring to 3 terms if they're prime. Now let's go to the 2b, where we have a polynomial that is not perfect, or it's in this form, um, ax squared plus bx plus c. Okay, so the first one is the easy factoring, and we'll start with that one. So the easy factoring, the reason why this becomes easy factoring is because the you don't see an a here, right? So if we don't see an a here, that means that a is 1. Okay, so whenever a is 1, we're going to factor this way. Okay, so these are some basic information, some rules to help you factor this easy factoring techniques. Okay, so we have the x squared minus 10x plus 24. If the last sign um, is a positive, then both the product of the two factors are going to have the same sign. Okay, if on this trinomial the last sign is a subtraction, then the product is going to have different signs. Okay, And then again, if the last sign is a subtraction, you have different signs. But again, always, if the last sign is an addition, the product will have the same sign. Okay, so let me do examples of what this means. Okay, so for instance, let's say that I want to factor out x squared minus 10x plus 24. Since that last sign was an addition, that means that my product is going to have the same symbol. They both are going to have, in this case, a subtraction. Okay, so here, what we want to do is we want to find two factors that give me the bx term. So the bx term is this negative 10. So for instance, I do the same thing that I did with the GCF. I want to find two numbers that will give me um, a product of the this 24, and then the sum is going to give me the bx term. Okay, so let's do first the factors of 24 to do the product part. Okay, I want to get a product of 24, and products of 24 are 1 and 24, 2 and 12, 3 and 8, 4 and 6. But again, I want to find the sum of two factors that give me that bx term, and again, that bx term is negative 10. So which of these two numbers would give me just the value of 10? And if you see here, it's 4 and 6. 4 and 6, if I add these two numbers together, give me 10. So if they have the same symbol, which is a negative, negative 6 minus 4 is going to give me that negative 10. So this expression, x squared minus 10x plus 24, factors in this format, x minus 6 times x minus 4. Okay. So hopefully this is the easy one, right? So let's do an easy factorization with this next example. Let's have x squared minus 7x minus 30. Okay, since that second symbol was a negative, we're going to have different signs. And then one of the rules is, since the first one was a negative, the factorization, the first one's going to be the negative, the second one's going to be the positive. But after that, everything um, everything turns out to be the same. Okay, we want to find two factors that when we multiply them together is going to give us that negative 30, and when we add those same two factors, they're going to give us that bx term, which is the negative 7. So again, I'm not interested in the sign right now because I know that they're different signs. So I want to look at all the factors of 30. The factors of 30 are 1 times 30, 2 times 15, 3 times 10, and 5 times 6. But which of these numbers would sum up to 7 having different signs? So if I see here, if I would have um, 3 and 10, okay, if I subtract 10 from 3, that's going to give me 7. But which one's going to have the negative? I want to keep a negative 7. So the number that's going to have the negative sign is a larger number, the 10, right? So if I subtract negative, or if I add negative 10 plus 3, that's going to give me my negative 7. So the factorization becomes x minus 10 and x plus 3. Okay, so this is how we use some of our foundation of the GCFs to also factor these trinomials. Okay? All right, so let's do these two other examples. So we have x squared plus x minus 20. Again, the last symbol is a subtraction, so we're going to have different signs. But then again, since on this particular one, the first one's a plus, that first one's going to be the plus, the second one's going to be the minus. Again, same process. I want to find two numbers, and when I multiply them together, it's going to give me this 20. So I first get the factors of 20, 1 and 20, 2 and 10, 4 and 5. But which of these two numbers, when I add them together, will give me a 1, right? So, and because they're different signs, they're, again, it's a subtraction with the signs, right? So it's just 4 and 5. So, 5 minus 4 will give me the 1, right? So the first one is 5, that has a positive. The 4 is with the negative. And this is the factorization, x plus 5, x minus 4. All right, let's do this last example. We have x squared plus 8x plus 15. Since the last symbol was an addition, both factors are going to have the same sign. In this case, it's a positive. Okay, so it's just about grabbing or knowing the factors of 15. 15 is 1 and 15 and 3 and 5, but which of these two numbers would give me a sum of 8? And that's just the 3 and 5. So this x squared plus 8x plus 15 factors in the form x plus 5 times x plus 3. Okay, so this one was the easy factoring, but we have one that's a little bit more complicated, and not that it's not as easy, but it just requires a little bit more work, or it requires us to add the grouping aspect of factoring. Okay, so let me give you an example. Okay, so here, whenever you have a trinomial that's in this form, ax squared plus bx plus c, that means that our a is no longer going to be 1, that we're going to have a value for a. We're going to factor this guy by grouping. But the first thing that we need to do is the factors that we need to find out is we have to find the two numbers that when A and C are multiplied are the terms that we're looking for. The bx term is going to remain the same. These same two numbers have to add up to our bx term, but this is the only difference when A is not 1. We have to find the factors of the product of A with C. So let me give you an example. Let's do this example 1. We have 3x squared plus 11x plus 10. Okay, so since here in my problem A is 3, the factors that I'm going to need to find are the product of 3 times 10. So it's 30. So what are the factors of 30? The factors of 30 are 1 times 30, 2 times 15, 3 times 10, 5 times 6. But which of these two numbers sum up to my bx term? Sum up to 11. And if you can see, my two terms are 5 and 6. 5 and 6 sum up to 11. So what I am going to do is I'm going to break up the bx term in this format. The 11x is going to be separated into 6x plus 5x. Okay, so that's all I did. I separated my bx term into the two terms that satisfy my condition. Now it just becomes a factoring of 4 terms. That means by grouping, I'm going to split it in half into 2 groups and factor out the 3x squared plus 6x. That's my group 1. My group 2 is going to be the 5x plus 10. So let's do the group 1. What can I factor? What is my GCF of 3x squared plus 6x? Well, that's the 3x. What's left over? The x plus 2. Let's factor out 5x plus 10. The only thing I can factor out is a 5. What's left over? X plus 2. Do you see what I have left over is the same thing on both? So that's my GCF now from grouping. X plus 2. What's left over? The 3x plus 5. And I factored it. Okay, I factored this trinomial that had a value of 3 instead of a 1. So it's still easy, but it's not as easy as the one before, right? Not all of them can be very, very easy. All right, so let's look at another example. Oh, no, actually, I'm done with examples. I think I went a little bit too fast here on the grouping. Let's see, if Ms. Chuka's here, did you want to go over inverses since we finished factoring? Oh, I think she left. Guys, so since we had just one group today, this is the only thing that I covered for you guys today, factoring. Hopefully this helps out with you. Um, so what we did, we put a presentation for those who are pre-cal 1. You can get a link to the stuff that is being covered in your pre-cal class in the 1.7, 1.8, which is inverses and all of that. So again, I'll pass it back to my presenters. Thank you for joining me today.
Thank you, Mr. Carizales. So if you guys would like to download a copy of the presentation, you can go to the top right corner and there's a little box with an arrow pointing down. You can download this presentation while it's still on the screen. So we do want to remind you guys about the previously recorded sessions, which are available on a YouTube playlist. This session will also be available on that playlist later today. Also linked was a short survey to help us improve our TVE sessions. So please take a few minutes to fill out that survey. And before you all leave, I want to share the TVE sessions that we will have next. So at 1 p.m. today, we will have a presentation covering student IDs, campus life, the Tejano Food Pantry, and the Tejano Ambassadors. We will be back with Happy Math Hour next week at 11 a.m., where Math 1314 will cover the Exam 1 review, and the Math 1324 will also cover their Exam 1 review. Our 1 p.m. session next week will be a presentation, Do You Have Any Cows by Christian Salas from the EPCC Mental Health Committee. Thank you all for coming in today. We hope you all have a lovely weekend. If you have any questions, feel free to use our chat box or your mic, and we hope to see everyone again for Happy Math Hour again.